day, grade 12 learners. Welcome to today's Physical Sciences revision lesson. My name is Dimpo Rampora, and this lesson is brought to you by the Northern Cape Department of Education in collaboration with Phakama Research and Development. Now, as we have said, that the focus of our lesson today is just going to be on paper 2 revision, right? What is it that you need to know in terms of the paper 2 that you are going to be writing? Firstly, you need to know the structure of the paper or the framework of the paper. You need to know that you are going to be given 10 multiple choice questions, and you are going to have structured questions, which will be about 130 marks. And you are going to be sitting for 3 hours, and the total of your paper is going to be 150 marks. And remember that this paper will not be marked by your teacher, but it will be marked externally. All right. Now, the next thing to remember is the different cognitive levels that you will be expecting to find in your examination. You'll be asked questions where you are required to remember or recall stuff. Questions that are going to rather test your understanding, applying and analyzing, as well as evaluating and creating. So it's very, very much important to look at all different types of questions. The next thing I want us to look at is the weighting of the content in terms of the marks, in terms of the knowledge areas. Remember, in chemistry, we are looking at 2 knowledge areas, which is the chemical change as well as matter and material. Remember, chemical change is out of 92 marks, and then your matter and material will be out of 58 marks. And all of this will give you that total of 150 marks, all right? Now that we have looked at the framework of the paper, the next thing is to look at what is it that I'm going to expect when I look at my question paper. The first thing that you're going to come across obviously will be the cover page, followed by your instructions. We'll talk more about the instructions in the next slide. But in terms of the structure of the question and the content, you'll be given multiple choice questions. Normally that is your question 1. You'll be given organic molecules, nomenclature, naming, IUPAC naming, we will look at that. Physical properties of organic compounds could be your question 3. And then your question 4 of your previous question papers, normally we have there the type of reactions. We also have rates of reactions, chemical equilibrium, acids and bases, galvanic cell, as well as electrolytic cells. Now, it's very important that as you practice your previous question papers, you take note of the mark allocation and check which question has more marks. All right. Now, the first thing that I want us to quickly look at is the exam instructions that I told you about. We indicated that the first thing that you're going to see is the cover page. Right after the cover page, you will see instructions. Now, it's very important that you read the instructions with understanding and you follow all of them. So I'm not going to go through each and every one of them. I'm just quickly going to jump to the one that I feel they are most important. So especially 8, 9, 10, 11, and 12, I feel these ones are most important. Though all of them, you must make sure you read and you abide by the instructions. Now, instruction number 8 says, show all your formula and substitutions in all your calculations. Number 9 says that round off your final numerical answers to a minimum of 2 decimal places. That one is very important, and you must give brief motivations, discussions, etc., where you are required to do so. And number 11, you are advised to use the attached data sheet. So it's very important that you use the data sheet that will be attached on your question paper. And lastly, make sure that you write neatly and legible. Okay, very much important. Now, let's quickly jump onto the structure of the question paper. We are quickly going to look at the multiple choice questions. What are the tips that I want to give you when you are dealing with a multiple choice question? 1, please make sure that you read the question carefully and try to read it with understanding, okay, as you are dealing with your multiple choice question. Then secondly, I want you to eliminate any wrong answers, okay? Any wrong answers that you see immediately as you read your multiple choice question, try to eliminate them. 3, you look for keywords. What are the keywords that I have or that I know in this particular multiple choice question? And then fourthly, I want you to use your logic and reasoning to try and solve the multiple choice question. And then number 5, I want you to practice time management. It's very much important that you don't waste time. Your 10 minutes, doing the multiple choice question, only one multiple choice question. Remember, you are only going to be given 3 hours to complete the 150 marks. So that one is very much important. Then 6, you need to make sure that you check your SI units, you check your conversions, especially when you are required to manipulate equations, or in a multiple choice questions where they require you to use certain equations or certain SI units to get to the final answer. Make sure that you check those important keywords. Then 7, I want you to review your answer. As soon as you have identified the correct answer, go back and look back as to if you are really sure of your answer, you review it. All right. And then 8, I want you to practice with previous question papers. Just practice your multiple choice questions. You can just take 2 previous question papers where you are only practicing multiple choice questions, and you will see that it is not as difficult as it seems. And then lastly, very much important, never leave a multiple choice question unanswered. You can rather try, you can rather pick or choose which one you feel that, this one could be the correct answer, but do not leave it unattended. All right. Very important multiple choice questions. Now we are quickly going to jump into question 2 of what we have seen in our previous question papers as organic molecules. What is it that I want you to remember there? Remember that because you are dealing with organic molecules in this specific chapter, I want you to remember how to define organic molecules. You need to remember how to define your hydrocarbon, your homologous series, as well as your functional group. Now, very much important here, I've highlighted for you. Please make sure that you remember the differences between homologous series as well as functional group. Remember, the homologous series is defined as a series of organic compounds that can be described by the same general formula. Very much important for you to remember the definition. And whilst we are dealing with a functional group, remember there we are looking at a bond or an atom or a group of atoms that determines the physical property of the group of organic compounds. So that is very important for you to be able to distinguish between the homologous series and the functional group. Now, over here on my screenshot, I did not take all the different types of homologous series because I know you know them. You know alkanes, you know alkenes, you know alkynes, you know alcohols, alcohols, as well as your haloalkanes. Yes. And then these ones that I have screenshotted here are the ones that I want you to make sure that you know them, because these are the ones that are giving us trouble. So remember, alcohols, aldehydes, ketones, carboxylic acid, and esters. That is where our problem is. Please make sure as you go back, you revise, you look at how they are structurally different. Okay, that is very important to remember. Remember, for you to see an ester, we said you just look at CoO is what's going to help you to see that you are dealing with an ester. And then with the carboxylic acid, you have that as your functional group. And then as your ketone, we have the C, and the double bond of oxygen is between 2 carbon atoms, and your alcohol has an OH attached to a carbon atom. Very much important also to remember the names of your functional group, especially for these 4. Okay, remember alcohols, because of the hydroxide, it must have an hydroxyl group. And your ketone has formal group, an aldehyde has a formal group, while a ketone has a carbonyl group. A carboxylic acid is easy to remember, carboxylic acid for carboxyl group. Very much important. The others, they are very easy to remember. Alkanes, we know they are single bonds. Alkenes is double bond, alkynes is triple bonds. So it's very easy to remember the description of the functional group with those ones. Nextly, I quickly want you to remember the differences between saturated and unsaturated compounds here. Remember, saturated and unsaturated compounds. Saturated, they don't consist of multiple bonds between carbon atoms, and then unsaturated, they consist of multiple bonds between carbon atoms. All right, very much important to remember all of that. Now, let's quickly jump on to what you also need to look at as you are practicing your question 2. Is to look at structural isomers. Remember, there there are 3 types of structural isomers. We have what we call the chain isomer. We also have what we call the positional isomer. And then lastly, we have what we call the functional isomer. Now remember that the chain isomer, the only difference is that they have the same molecular formula, but what is different is the types of chains. So if you are given a straight chain, you change it to a branched chain. If you are given a branched chain, you change it to a straight chain. Positional isomers, remember, you are just moving the position of your functional group. If your OH, okay, was on carbon number 1, all right, you just move it from carbon number 1 and then you move it either to carbon number 2. Okay, we are just moving the functional group. Very much important to remember the difference. Remember, positional isomer, the chain type must remain the same. Then functional isomers, what is it that you must remember? They still have the same molecular formula. What is different is the different functional groups that you are going to have. Remember, there are 2 pairs that are always working together. Under functional isomers, we have a ketone that is always going to work with an aldehyde. Okay, why do they work together? Because they both have 1 oxygen and it's easy to keep the number of carbons and hydrogens the same. Another pair that works together is the carboxylic acid. Okay, carboxylic acid with a what? With an ester. Again, it's easy to keep these ones also the same because they have 2 oxygens, and what you just need to do to keep the number of carbons and keep the number of hydrogens what? The same. We're quickly gonna go back to IUPAC naming. What is it that you must remember here? Your IUPAC naming is normally 3 marks, okay? It's very much important that you remember the rules of IUPAC naming. We are not going to waste time to go through how to do the IUPAC naming. Please make sure you go back and look at those rules. But however, there are some few tips that I would like you to remember when you are dealing with IUPAC naming. You must remember that the hyphens are used between the word and the number. As you can see here, I have a number, which is 2, and then I have methyl pentane rather. Between the number and the name, there must be a hyphen. There is your hyphen there. Very much important to remember. Commas are used between numbers, as you can see, 2, 3. Between a number and a number, we put a comma. Between a number and a word, we put a hyphen. Very much important. And then 3, marks are deducted if the hyphens or the commas are omitted. Very much important that you might lose penalized 1 mark, okay, if you are not including any of those. Then number 4, the hyphens should not be used between the words. Remember, between a word and a word, we don't put anything, all right? Very much important. It's always between a number and a number or a number and a word. And then 5, all IUPAC names are written as 1 word except esters and carboxylic acids. This is very much important to remember as you are doing your IUPAC naming. The following: propanoic acid and ethyl propanoate, because propanoic acid is a carboxylic acid while ethyl propanoate is an ester. Only those 2 are exceptional cases where we only have 2 words. And then methyl propane and chloromethane and any other homologous series or functional group or whatever structural formula that you are required to name, you must remember that you must give it only 1 name and make sure that those names are combined like this one, okay? 2-methyl pentane is an example of that. I hope you guys will remember all of this, and this is definitely going to assist you. Now we are done with question 2. I quickly want to jump on to, or rather before I move on to question 2, I just remembered something here. Remember, there are different types of structural formulas that you must know. Very much important for you to know when the examiner says to you, write the structural formula or write the molecular formula or write the condensed structural formula. You must remember what is the difference between those 3. Remember, a molecular formula would be, an example I would give you as C2H6 would be an example of a molecular okay, formula. Okay, very much important to remember this. Why is this referred as a molecular formula? Because it is a chemical formula that indicates the element that is in the compound and the number of atoms that are in the compound. The element that is in the compound is carbon and hydrogen. How many atoms of carbon do I have? Is 2. How many atoms of hydrogen do I have? Is 6. So that is the molecular formula. When the examiner says write down the molecular formula, you know exactly what you are writing down. The next one could be write down the structural formula. The moment the examiner says structural formula, you know that you must give us a structure. So you must show us the bonds using the structure. Which one is bonded to which one? So when we speak structural formula, it shows which atoms are attached to which molecule, and we represent the chemical formula using the symbol of the element, and we use the lines to show the bond. Which line? This line over here, this line over there, this line over there indicates the bond between one atom and the other. So this one will be referred to as the structural formula. Very important, guys, to know the difference, because the examiner can say, write down the balanced molecular formula for this particular reaction, or write down the balanced structural formula for this particular reaction. So you need to give us the direct structure or formula rather that the examiner is looking for. And then the last type of formula is what we call the condensed structural formula. The condensed shows us a way in which the atoms are bonded together in a molecule. But remember, it does not include the bond lines. Okay, so that means if I were to look at this that I've given here as an example, what will be your condensed formula? It will be CH3 and another C bonded to 3 hydrogen. So this one will be referred to as the condensed, okay, formula. Condensed structural formula. So very much important to know what is it that the examiner requires you to do in this question. Also pay attention to name or formula. So when the examiner says give the name, you give us the name, methanol. Okay, when the examiner says give us the formula for methanol, then you write the actual molecular formula for methanol. So it's very much important to do that. Now that we are done now with question 2, I hope all those tips are going to assist you as you prepare for your final examination. Let's quickly look at question 3 under physical properties of organic compounds. Remember, even here we are still dealing with organic molecules, but we are specifically zooming into the 3 physical properties of organic compounds that you must know. Remember, it is the boiling point, it is the melting point, as well as the vapor pressure. What is it that you must remember about these 3 rather? You must remember their definitions. Now, remember your definitions are extremely important and they must be according to the exam guideline. So which exam guideline are we using? The 2021 examination guideline. Very important. So how do we define melting point? Remember, it is the temperature at which the vapor pressure of a substance is equals to the atmospheric pressure. And then how do we define melting point? This is the temperature at which the solid and the liquid of a particular substance are at equilibrium. Very much important to remember that definition. And while the vapor pressure, it is the pressure exerted by a vapor at equilibrium with a liquid in a closed system. So very much important to know these definitions, because the examiner can ask you to define any of that. They can also ask you to define hydrocarbon. They can also want you to define saturated compounds or unsaturated compounds also in this particular question. So they are not limited to only boiling point, melting point, or vapor pressure, because it is still under organic molecules. Very much important. The next thing to remember is that in order for us to know the relationship between the boiling point, the melting point, and the vapor pressure, we remember that the higher the boiling point, the higher the melting point, but the lower the vapor pressure. And remember, how do we identify that substances have a higher boiling point, a higher melting point, or a lower vapor pressure? We look at the intermolecular forces that are present. Remember, there are 3 types of intermolecular forces that you must know, arranged from the weakest to the strongest. We have the London forces, your dipole forces, as well as your hydrogen bonds. Now over here, I hope you still remember our AAA, Hague, AC. This is what is going to assist you to remember which organic compounds consist of which dominant intermolecular forces. All right. Now remember, all organic compounds, they all consist of what? Of London forces. But the strength of the intermolecular forces, they differ in other organic compounds than the other. Remember, the AAA will mean that here we have your alkanes. Remember, you have your alkanes, your alkenes, as well as your alkynes. Okay, these three, they are all under what we call London forces or dispersion forces, or induced dipole forces, depending on what your educator has taught you in your school. So another one, Hague, remember, H4, haloalkanes. We have our haloalkanes. We have A here, our aldehydes. Please don't confuse the A thinking that the A is an alcohol. Remember, the A is the aldehyde, and then the K over here will be your ketone, and then the E over there will be your what? Your ester. Okay, and all these four, which intermolecular forces are stronger there? It is your dipole forces. I hope you still remember all of that. Then lastly, AC, remember we have then our alcohols, as well as C, which is our carboxylic acids. Okay, remember the alcohol has one side of hydrogen bond, while the carboxylic acid, they have two sides of hydrogen bonds. That makes the carboxylic acid to be the one that has the strongest intermolecular forces. I hope you still remember all of this, and this AAA Hague AC will assist you to remember which intermolecular forces consist of which organic compounds, or which organic compounds consist of which intermolecular forces. Another thing I want us to remember here is the differences between dependent and independent variable, because in this particular question, the examiner can give you an investigative type of question. So when they are giving you an investigative type of question, you need to know how to answer the question in terms of dependent variable as well as independent variable. Now, it's very important to always remember that your dependent variable, it's either going to be your boiling point, your melting point, or your vapor pressure. Why is it going to be any of those three? Because the physical property is the one that must be the dependent variable, because it is the one that, we are trying to see the effect from, to say, when we change this particular thing, what happens to the boiling point, what happens to the melting point, and also what happens to the vapor pressure. Now, the independent variable is going to differ according to the scenarios that the examiner might give you. Now, the first scenario that the examiner can give you, they can give you substances that belong to the same homologous series or the same intermolecular forces, such as three alkanes. They can give you alkenes, methane, butane, and pentane. Okay, so they can give you any of those three. They belong to the same homologous series, or they can use alcohols, or they can use aldehydes. It doesn't matter. All you need to know is that when you are dealing with substances that belong to the same homologous series, what is it that you are going to use as your independent variable? What you are going to be using as your independent variable is what made the change in order for the boiling point to increase or decrease. So because their homologous series is the same, what made the change will be either their chain length will be the ones that are affecting the intermolecular forces, right? Remember, as the chain length increases, then the strength of the intermolecular force will also increase. Now, another scenario could be, in scenario number 2, could be that the examiner can give you substances that belong to different homologous series with different intermolecular forces. Now, how do you deal with such a question? Therefore, what would be your independent variable? Your independent variable will obviously be your intermolecular force, intermolecular forces. Why intermolecular forces? Because those are the ones that have changed, that made the boiling point to change, that also resulted into the melting point to change and the vapor pressure to also change. So it can either be the intermolecular force, or we can say the type of homologous series that we are given, or the types of what? Of functional groups that we are given. Okay, so if they have different functional groups, different homologous series, and different intermolecular forces, that means that those ones will be your independent variable. If any of this is the same, the intermolecular forces are the same, the the homologous series rather is the same, or also the functional group is the same, you are only going to look at the chain length. Very much important to remember. Lastly, fully explain. The examiner will always say, fully explain why the boiling point of this particular substance is higher or lower. What is it that you must remember to do? In this case, you must remember ice. Now, how is ice going to assist me? Ice is going to assist me by doing what? By fully explaining why am I saying this particular intermolecular force will have a higher boiling point or a higher vapor pressure or a lower melting point. So what is it? What does the ice stand for? Remember the ice here, you talk always about the intermolecular forces that are present. Okay, molecular forces. Okay, that's what you look at. And then C, what do? You compare the strength. Okay, the strength of what? Of the intermolecular force. Then lastly, E, you talk about the energy required to overcome the intermolecular forces. The energy, sorry about that, energy required to overcome. What are we overcoming? The strength of the intermolecular forces. I hope this is going to assist you. We will also look at more examples, especially I just chose, from a previous question paper to say, let's try to take what we just revised and then put it into practice so that you can see what we meant by the examiner can give you different types of questions. Now, here we have a learner conduct a scientific investigation to compare the boiling point of organic compounds belonging to different homologous series. So already here in your mind, you should be thinking, am I dealing with scenario 1 where I have the same homologous series, or am I dealing with scenario 2 where I have different homologous series? So as you can see, our homologous series is what? Is different. So already you should know already what is your independent variable and what is your dependent variable. Propan-1-ol, ethanoic acid, propanol are used for the investigation. His results are shown in the table below. We have compounds A, B, and C, and then we have the different boiling points over there. As you can see, the boiling point is increasing from compound A to compound C. Now let's look at what the examiner might ask you. 3.1 could be, for this investigation, name the independent variable. As I said, that this type of question, the examiner can give you investigative types of question. So the independent variable, what did we say? The independent variable is what changed that has resulted in the boiling point to increase or decrease. So what is different? What is different here is the homologous series. I have propan-1-ol, ethanoic acid, as well as propanol. So that means my independent variable will be homologous series. Is this the only independent variable that I have? No. Remember, if they have different homologous series, that means they also have different functional groups. If they have different functional groups, that means they also have different what? Different intermolecular forces. All right, very much important to remember. Again, for this investigation, name the dependent variable. What is the dependent? The dependent variable, we said it can either be the boiling point, the melting point, or the vapor pressure. So what are we investigating here? The boiling point. Therefore, the boiling point will be our the dependent variable. Boiling point will be the dependent variable. I hope you guys are still with me. You are remembering all of this. Let's quickly jump on to 3.2, which says, will the vapor pressure of propanol be lower or higher than the vapor pressure of propan 1-ol? Remember, what is the relationship between vapor pressure and boiling point? The higher the boiling point, the lower the vapor pressure. So over here, I have propanol. Propanol, I know that it has what? Dipole, strong dipole forces. So since it has stronger dipole forces, then your propan 1-ol has stronger hydrogen bonds, hydrogen bonds. Now that I know which intermolecular forces are present, I then say which one has a stronger intermolecular force. So the stronger the intermolecular force, the higher the boiling point, the lower the vapor pressure. The weaker the intermolecular force, the lower the boiling point, the higher the vapor pressure. So I already know that my answer is going to be higher than will be the correct answer, because the vapor pressure of propanol will be higher than that of what? Of propan 1-ol. But it doesn't end there. It says, explain your answer by referring to the type of intermolecular forces present and the energy. As you can see there, you have 3 marks. Where does the 3 marks come from? First, you have to answer, is it going to be higher than, lower than, or equals to, or whatever that the examiner has used, or terminology that the examiner has used. So obviously we said the answer will be higher than, right? So 1 mark for higher than. Where does the other 3 marks come from? The other 3 marks comes from our eyes. Remember, you must talk about the intermolecular forces that are present. So which intermolecular forces are present in propanol? Propanol has what type of intermolecular forces that are stronger there? The ones that are more dominant. We have dipole forces with the London forces, of course. Then what do we have under propan 1-ol? Under propan dash 1-ol, I have, what is it? It's hydrogen bonds. Hydrogen bonds. Now, what do I know about the two? Now I go to compare. What am I comparing? I'm not comparing the compounds, but I'm comparing their intermolecular forces. So what are we going to say? We're going to say weak dipole forces than hydrogen bonds. Very much too important to say that. You cannot say weak propanol than propan 1-ol. That means you are now comparing the compound. You are not comparing the intermolecular force. Very much important to remember that as you are preparing for your exam. Then E, we talk about the energy required. Which energy? Of propanol, because propanol, we said, is higher than. It will have a higher vapor pressure. Why? Because dipole forces are what? Are weaker intermolecular forces than hydrogen bonds. Therefore, less energy. Energy is required. Okay? Required to do what? To overcome the strength of what? Of the weak dipole forces. Okay, excuse my handwriting. I didn't have enough space for you to for me to write that for you. But I hope you guys are still with me and you remember all of this that you did with your teachers. Now remember, we said we are looking at now question 4, which is normally types of reactions under organic molecules. So we are still under organic molecules. All the definitions under organic molecules, they still comply here. So your homologous series, functional group, saturated, unsaturated, hydrocarbons, all the different definitions you must still know also when you come to this question. Now, what is it that you must remember? You must remember the different types of the types of reactions that we have. All right. The first one I'm going to quickly look at is esterification, to help you remember. But esterification, sometimes the examiner can put it in question 2, all right, under those organic molecules where you were doing your IUPAC naming. Sometimes you can still find it also in types of reactions. So it's very important that you know that this chapter it's in sync, because it is still under organic molecules. All right. Now, under esterification, what is it that I want you to remember? If you can just write under an esterification, ACE plus water. Why ACE plus water? It will help you to remember that, for the process of an esterification, I need to react. An alcohol must react with a carboxylic acid, all right, to give you what? To give you a product of an ester plus water. All right, this is just the process of esterification, but please do not forget the catalyst that we use to speed up the reaction. And the name of the catalyst that we use is concentrated sulfuric acid, all right, which is concentrated H2SO4. Now, it's very important to remember that the examiner can say to you, what is the name of the catalyst that was used to prepare the ester? When they say to you, what is the name of the catalyst? That means they want you to write in full that it is sulfuric, okay, acid. That's what the examiner is looking for. But if the examiner says, write down the formula of the catalyst that was used to prepare the ester, what is the examiner looking for? The examiner is looking for the molecular formula, which is H2SO4. So very much important that you follow the instruction and you always give the answer specifically to what the examiner was asking you. Very much important to remember. Now, if you remember this, you can remember that an ester, remember, you remember it by COCO, okay? That's very much important to remember. That is just an example of esterification that you must go back and look at. The next thing that I quickly want us to look at is another type of reaction, which is oxidation or combustion. Again, this type of reaction, you can still find it in question 2, because the examiner can say, use the following alkane to write down a balanced molecular formula of the process of combustion that is going to take place. So you must know that when they say combustion, they're referring to oxidation, or if they say oxidation, they're referring to what? To combustion. What is it that you are looking for? You are always going to work with an alkane. So we are only going to do combustion of alkanes. So you take whatever alkane that you are given, all right, on the question, you just reacted with what? With oxygen. So the reactant is always the same. Your reactant will always be oxygen. And what will be your product? Your products are always the same again, which will be carbon dioxide, which is CO2, and H2O, which is your what? Your water. So it's very, very much important to know if that the examiner says to you, write down a balanced, chemical equation for the formation of the combustion reaction for this specific alkane. The first thing that you need to do is to remember, what do you react the alkane with? You always react it with oxygen, because when we are combusting, we are burning. So anything that you burn, it is going to react with oxygen in the atmosphere, and then your product will always release carbon dioxide, okay, as well as water as your product. So the next thing that the examiner can then say, they can always say to you, balance the equation. This one is always a problem. When learners see the word balance the equation, write down the balanced molecular formula for the combustion of this particular alkane. You tend to give up along the way because of the word balanced. So you don't really have to worry, because if you know what is the reactant and you know what are the products, you always get mark for the reactants and you always get mark for the product. But remember, your alkane, if for example is H6 rather, which would be an ethane. So if you write it correctly as a molecular formula, okay, depending on what the examiner is asking, did they say use molecular formula? Did they say use condensed formula? Or did they say use structural formula? And now that you remember the 3 different types of structures, you know exactly what the examiner will be asking you. So if they say molecular formula, you know that you must write it as like that. C2H6 will react with O2 to give you CO2 and H2O. Yes, guys, now let's look at let's remind you of the different types of addition reactions, because we already know what the abbreviations mean, okay? The different types of addition reaction, remember the first one is hydration. Now remember hydration, we are adding. What are we adding? We are adding water, okay? Very much to remember. What is it that is the reaction condition for hydration? Very important, because there is water, you need more water for the reaction to happen. So we have excess water, okay, as a reaction condition. We also have concentrated H2SO4 as a reaction condition. Very much to remember the type of addition reaction, the reaction conditions also, so that it will be easy for you when you are dealing with this chapter. Then let's look at another one, which is hydrogenation, right? Remember, we've spoken about that another type of addition reaction. This one speaks for itself. Hydrogenation, we are adding a hydrogen. Very much important. Since we are adding a hydrogen, what are the reaction conditions for me to add a hydrogen? The reaction conditions is that it must have a catalyst, and that catalyst can either be PT, PD, or Ni. I hope this can help you. Then the third one, the type of reaction is hydrohalogenation. Remember also hydrohalogenation. What are we adding? We are actually adding a hydrogen and a halogen. What is that X? That X is the halogen, which can be a chlorine, a Br, a fluorine, or an iodine. Right, that is very much important. Then nextly, what is it that you must remember? The reaction conditions under hydrohalogenation is that there shouldn't be any water. So no water must be involved during the reaction. And lastly, under addition reaction, the other type of addition reaction, which is the last one, is halogenation. Okay, remember halogenation. Halogen, what are we adding? We are adding X2. That X2 can either be a chlorine, a bromine, a fluorine, or an iodine. Right. What are the reaction conditions for this one? Lucky you, there are no reaction conditions for this one to remember. Okay, only under addition reaction. And those are the 4 types of addition reactions that you must remember. Then remember under elimination, we said you use the SU abbreviation, saturated reactant, that gives you unsaturated product. Then the type of reaction will be elimination. Now, what type of elimination reactions do I need to remember? I have dehydration. When I need water, that means that I am dehydrated. Therefore, make that a process that will be dehydration. So if I am dehydrated, what am I removing? Because remember, elimination, I am removing what? Water. That is what I'm removing from the reaction. And then what is it that I have as a reaction condition for this to take place? Remember, this must happen under concentrated H2SO4, also that acts as a catalyst, and we must also have some heat in the reaction. Now the third one, to help you remember we have dehydrohalogenation. Oh, this one is the long one, but very much dehydrohalogenation. What am I removing? I am removing a hydrogen and a halogen. Remember that X can either be chlorine, bromine, fluorine, or iodine. All right. Now, what is it that is my reaction condition for this one? Here, I need to have concentrated strong base. Okay, concentrated strong base plus what? Plus heat. Very much important. And what you must remember is that when you are dealing with dehydrohalogenation, you have 3 products that will form. All right, very much important to remember that. Then lastly, you have cracking. Okay, remember when you are cracking, you are actually breaking down a longer complex organic compound or molecule into simpler organic molecules. Okay, now what is it that we are cracking? There are 2 products that can always form. Okay, we are cracking normally alkanes. All right, so what are the products? You can either form an alkene plus hydrogen, or you can form an alkene plus an alkane. So depending on how the cracking process took place, but what are the conditions? Remember, temperature. Okay, temperature must increase. And what else is a reaction condition? You also need a catalyst in the reaction, even if you are not specific as to which catalyst we are using. All you need to know is that. Then quickly, let's look at the last one, under substitution. Again, we have 3 types of substitution reaction. We have actually 2. It's just that the other ones are just, it's the same thing, it just differs what you are substituting. So we have hydrolysis. Okay, so there are 2 types of hydrolysis reaction. Is either you are substituting with water, using water, or you are using a strong base. Okay, you are substituting using a strong base. Very much important. But the 2 they are different because of their reaction conditions. If you are hydrolysis with water, if you are hydrolysis, you are doing the hydrolysis reaction and you are using water, that means that the reaction condition, you must dissolve that particular substance in what? In alcohol. Okay, but when you are using a strong base, what you must remember is that you have to use a what? A dilute. No, rather, sorry about that. You must actually use a dilute. I was correct. Yes, a dilute strong base. Okay, with extra heat, with some extra heat. These are the reaction conditions, guys, that you must remember to deal with this one. If we don't know them, then we won't be able to do well in this chapter. Then the last one, under the substitution reaction, remember, saturated reactant to a saturated product, the type of reaction is substitution. So what are we doing here? It's halogenation. You will see something. There is halogenation under addition and there is halogenation under substitution. What is the difference? Under addition, your reactant will be unsaturated. Under substitution, your reactant will be saturated. Very much important to remember. What are we? Halogenation. What are we doing? We are also substituting a what? A halogen. When we are substituting a halogen, what are the reaction conditions that you must remember? You must remember heat is what we need. UV light can also be another reaction conditions, and as well as what? Sunlight can be used also as a reaction conditions. So guys, as I've already made a point for you here, that please remember your reaction conditions. That is the only way we can do well in these 3 types of what? Of reactions. I hope this has assisted you and it will assist you as you look at previous question papers. Now let's quickly move on to Markovnikov's rule. Yes, I forgot to mention for you here that you must not forget to implement Markovnikov's rule as you are doing the types of reactions. Remember, the Markovnikov's rule only says that you always put the hydrogen on a carbon that has more hydrogens, and you put either a halogen in a carbon that has less hydrogens. Okay, remember that when you are dealing with Markovnikov's rule, you will always rather form a major product. But if you don't follow Markovnikov's rule, you are going to form a minor product. Very much important to remember. Now, in this type of question, again, guys, question 4 is very long, okay? That is why we are also taking very long to deal with it. In question 4 here, quickly, I want us just to use our abbreviations that we just used quickly to see if we will be able to remember, or how to use the flow diagram. Because, you know, sometimes the examiner likes to give you a flow diagram here, but some of us, we are unable to see how to use it. Now, I'm going to give you an advice. You look at the arrow. Where the arrow starts, that is your reactant. Where the arrowhead is pointing, where your arrowhead is pointing, that is your product. Okay, so the arrowhead starts here. That means ethene is a reactant, and then ethane is a what? Is a product. The next thing that you say is that, is ethene saturated or unsaturated? I know ethene is unsaturated. How is my ethane? It is saturated. So if I have USA, what type of reaction is it? Is addition. So B will be an addition type of reaction. Right, very important. Then you can check what is it that I've added. You will see that from here I had a double bond, then now I have single bonds everywhere. That means I have added a hydrogen. And what will be your type of addition reaction here? It will be hydrogenation. Let's quickly look at D. If we look at D, again, look at the arrow pointing away. That makes ethane unsaturated again. That will make ethanol, which is an alcohol, what? Saturated, because there are single bonds between carbon atoms for an alcohol. Now, what is it? What type of reaction? USA again. That means D is also addition. Okay, what did I add? For me to have an alcohol, that means that I've added water. Okay, so if I've added water, what type of addition reaction? It will be hydration. Now let's quickly look at F. F again is pointing towards. I just want us to exhaust all the arrows that are facing away from ethene. It will make ethene unsaturated, then bromoethene, which is a haloalkane, will be saturated. Therefore, what type of reaction will FB? It will also be addition reaction. And what type of addition reaction is it going to be? It will be a hydrohalogenation, because as you can see, I have a bromoethane. That means that I've added a hydrogen and a halogen in the reaction. And then anything that is opposing your addition reaction, that will be your elimination, because you are removing from what you have added. So let's look at C. That will be an elimination reaction, because that means now I'm starting from ethanol. That will make ethanol a what? A saturated reactant, and the arrowhead points to ethane. That will make ethane an unsaturated product. So if I have saturated reactant to an unsaturated product, the type of reaction will be elimination. So E, I have elimination. I mean C is elimination. So what did I eliminate? What I added. So I'll eliminate what? Water. So what is the type of elimination? Is dehydration. So let's quickly look at E over here. Again, I'm moving from saturated to unsaturated, saturated to unsaturated. The type of reaction is elimination. E will still be elimination. What did I eliminate? What I have added. What is the type of elimination reaction? Dehydrohalogenation. And then lastly, we look at G and H. We are moving from saturated to saturated. The type of reaction G will be substitution. All right. And then again, H, saturated to saturated. The type of reaction will be substitution. Guys, I hope all of this is going to assist you as you prepare your examination. And we are going to do better now when we are dealing with types of reactions. Now, here are some tips, more tips when we are dealing with type of reactions. All hydrocarbons will undergo combustion or oxidation. All saturated organic compounds such as alkanes, alcohols, and haloalkanes will undergo substitution and elimination. Unsaturated hydrocarbons will undergo addition reactions such as hydrogenation, hydration, halogenation, and hydrohalogenation. And B, addition reactions of alkynes are not examinable. So we are only going to be working with alkenes. All right. Esterification is a reaction between a primary alcohol, very much important, not just any alcohol, but a primary alcohol with a carboxylic acid. And we know that the product will always be an ester plus water. Guys, thank you so much for question 4. We are quickly now going to jump into question 5, which is normally rates of reactions in your previous question papers. What is it that I want you to remember there? You must remember your grade 11 revision work, where you were dealing with exothermic reactions as well as endothermic reaction. What is it that you must remember under exothermic reactions and endothermic reactions? You must remember how to define, okay, endothermic reactions and how to define what? Exothermic reactions. Now remember, exothermic reaction means that the energy is released to the surroundings, while the endothermic reaction is energy has been absorbed, okay, into the system. And remember the definitions for activation energy as well as activation complex, okay, as well as heat of reactions. Now it's very important to differentiate rather the differences between the two graphs, which is an exothermic reaction graph as well as the endothermic reaction graph. Remember, this work was done in grade 11. It's very important to take note that in an exothermic graph, you have more of the reactants than the product. Okay, you have actually more reactants and less products. And then under endothermic reactions, you have less reactants and more products. So it's very important to remember all of that. Now, the next thing that I want us to remember under rates of reaction after we are done with our grade 11 revision, the next thing I want us to look at is factors affecting the rate of reaction. All right. And also how to define rate. Okay. Very important to go back to exam guideline and look at that. What are the factors maybe that affect the rate of reaction? Remember, we have either increasing or decreasing temperature, increasing or decreasing surface area, increasing or decreasing concentration, adding a catalyst, as well as the nature of the reactant. Now, what is the relationship between increasing temperature with the rate of reaction? As we increase the temperature, remember, the rate of reaction will be faster. When we increase surface area, rate of reaction will be faster. Increasing concentration, rate of reaction will be faster. Adding a catalyst, rate of reaction will be faster, as well as the nature of the reactant, depending on which nature of the substance we are dealing with, either a solid, a liquid, or a gas, then it will determine if the rate of reaction will be faster or slower. Remember, when you are doing your factors that are affecting the rate of reaction, it's very important that when the examiner gives you an investigative type of question, you identify which factor has been investigated. Once you are able to identify which factor has been investigated, then you must look at what is it that the factor is doing. Is it being increased or is it being decreased? We know that if we increase temperature, the rate of reaction will be faster. But if we decrease the temperature, the rate of reaction will be slower. And remember, increasing temperature is an exothermic reaction, while decreasing temperature is an endothermic reaction. And remember, exo and endo in terms of change in enthalpy. Now, remember, change in enthalpy is less than 0 if you are dealing with an exothermic reaction, and your change in enthalpy is greater than 0 if you are dealing with an endothermic reaction. All right. If it's change in enthalpy less than 0, then that is an exothermic reaction. Very important. Now, please don't forget how to state the collision theory. Particles must collide. Particles must collide with the correct orientation, or they must collide with effective collisions per unit time. If you know how to state the collision theory, then you must remember how to use the collision theory, how to apply the collision theory. If they are saying explain in terms of increasing temperature, use the collision theory to explain why increasing temperature will affect the rate of reaction. Another thing that I quickly want us to look at or to remember is the graphs that are associated with the rate of reaction. Basically, the Maxwell-Boseman distribution curve is very much important to know how to label it and remember what are the different y-axis, what is it that you are given, and what you are given on your x-axis. Remember, on your x-axis will always be your energy, and on your y-axis is your number of particles or the number of molecules. Now, very important, you can see, pay attention to the shaded area. Remember, the shaded area will always represent the number of particles that have enough energy to do what? To react. While the unshaded area, we are looking at the number of particles that do not have enough activation energy that are needed to do what? To start reacting. Very much important to remember the difference between the shaded area and the non-shaded area. While we are still talking about that, I want us to look at to remember the different graphs under temperature, temperature, concentration, as well as catalyst. So there are 3 graphs that you must remember. The first one is there are 4. The first one is the actual Maxwell-Boseman distribution curve. The next 3 is the temperature graph, the concentration graph, as well as the catalyst graph. So the first one I'm going to show you is the temperature graph. Remember, the temperature graph, you will still have your number of of molecules over there or particles, you still have your energy over here, okay, which is your x-axis. Remember, you still have your graph will always start at 0, okay, and then from there, because we are dealing with temperature versus time graph, you will always be given two graphs. The two graphs, if you are dealing with temperature, always remember temperature graph, the graphs will always cross each other. Where are they crossing? There they are. They are crossing there to form a T for what? For temperature. So remember that is the temperature graph, the shape. Now also remember that the one with the lowest peak, that will be this one, T2, if this one is what? Is T1. T2 is the one that will represent higher temperature. Why? Because it has more particles that have enough energy to do what? To react. Remember, we are always looking at the shaded area. If you compare the shaded area here and the shaded area there, you can see the one with the highest number of particles will be T2. That will have enough particles that will be needed to do what? To react, and that will have effective collisions per unit time. That is the temperature graph. The next graph that I want you to remember, it will also start at 0. It will also form the Maxwell distribution curve. But now the difference will be that the two graphs, they don't touch or cross. If they don't touch or cross, that means you are dealing with concentration graph. Okay, the two concentration, you have C1 and C2. If they ask you which one will indicate a higher concentration, you already always come to the shaded area. You say the one with the highest number of particles that have enough energy to react is the one that will do what? Will mean increasing concentration. So the correct one will be C1, that will be increasing concentration. Remember, as you increase the concentration, we are increasing the number of solid particles in the solution per unit volume, and then more particles will have enough energy that is equals to or higher than the activation energy, and then we'll have more effective collisions per unit time. So the examiner can say, use the collision theory to explain why C1 represent increase in concentration. All right, very much important. Another graph that I quickly want to show you, the last one, it is the catalyst graph. So the catalyst graph does not really have two graphs if they are using the Maxwell distribution curve. It will always be one graph. But what you will notice is it will always have two activation energies, okay? So you have activation A1, activation A2, the A2 there, all right? Now they will always ask you which one between A1 and A2 indicates the most catalyzed route. So the catalyzed route will be A1. Why? Because it shows a lower activation energy. So the lower the activation energy, that means that route is the catalyzed route. Because remember, a catalyst, it is the substance that lowers the activation energy, okay? It speeds up the chemical reaction by lowering the activation energy. Now, another way that question could be asked also is that the examiner can either give you an endo or an exothermic graph also. If they give you an endo and exothermic graph, what you look for is the dotted lines, okay? Those dotted lines over there will be indicating that is your catalyst, or that is the catalyzed route that is being taken, which is the shortcut towards the final destination. All right, I hope you guys are going to go back and look at these graphs, and they are going to assist you as you prepare for your final exams. So that this question can vary from an investigative type of question, or it can be just a straightforward question. So if it's an investigative type of question, remember they can also ask you what is the dependent variable and what is the independent variable. Remember, the dependent variable is what you are investigating, which is the rate of reaction. So the dependent variable will always be the rate of reaction. What will make the rate of the reaction to be faster is what is it that you are going to change, and what is it that you are changing. Either the temperature is increased or decreased, or the surface area is increased or decreased, or the concentration is increased or decreased, or if they've added a catalyst, or the nature of the reactant that they have given you. I hope you guys now understand the differences between dependent and independent variables, and you will know how to deal with this question. Another thing that I want to make you aware of is the examiner can also ask you to name the apparatus. So you need to know the different experiments related to rate of reaction. Experiments of surface area. Surface area can also be known as the state of division. So you need to familiarize yourself with the different language that the examiner can be using in this part of the section. Also, know which apparatus you are using. If you are given an experiment type of question, know how to label them. All right. Very, very much important.